So our next presentation is Dr. Andrew Woods, who you all know is one of the chairs of the SD&A conference, so he really needs no introduction, but he will be showing some 3D content, so hold on to your glasses. So welcome, Andrew.
So this paper is on a similar topic to what Stephen and I were talking about this morning, but sort of extended to another sort of field of displays. This is specifically about image distortions in large-scale immersive 3D display systems, and specifically discussing with regard to two displays that we've got, the HIVE visualisation facility at Curtin University called the Cylinder and the Wedge. So stepping back to what 3D map was originally designed for, that was for simulating flat screen displays, flat screen 3D displays, using a virtual model of a camera system, looking at a grid, and then working out what that would look like on a standard flat screen display. So that was written up in a paper presented at the 1993 Stereoscopic Displays and Applications conference, and it also revealed two types of distortions that were present: depth plane curvature, shear distortion, and also the other well-known one, which was keystone distortion. But it only considered flat or planar displays. So in the facility that we established at Curtin University in 2003, the space is a gallery space, 15 metres by 15 metres, and 4 large-scale displays are in each of the 4 corners of the facility. There's a lot of facilities installing large-screen immersive 3D displays, as we've seen in many of the presentations so far in this session. The 2 displays that we specifically installed that have 3D capability are this one, which is the Cylinder display, and that features a 3-metre high screen, 180-degree field of view, and 8-metre diameter. It's projected using 3 TLP projectors on the roof, warped and blended together. The Wedge display is 2 rear projected screens mounted at 90 degrees to each other, 3.8 metre diameter. We envisaged at the beginning we'd used a mixture of, we used them for a mixture of virtual environments and data visualisation. We found that the Cylinder display was extremely good for providing groups of visitors with a virtual environment, virtual reality experience, as I think it might have been, maybe it was Dan or Jürgen who sort of commented about these types of displays being very good for group interaction. This particular display can accommodate up to 20, 25 at a stretch. If they can stand nice and close together, you can fit 25. But only one person can be at the sweet spot. Other users will see some level of image distortion, but how much, and how much is acceptable? The other question is, how much does the distortion vary between the different displays? Now, when we first set up this facility, and this is the Wedge display on the right here, we had someone visit us to set up the Wedge display, and he set it up and he said, right, that's it. And I stood where he was standing and I said, well, it still doesn't quite look right. And I looked over at him and noticed that he was about 10 centimetres shorter than I was, and when I went down like that, oh, that's it. So it was actually quite sensitive. And what we found is that the sharp 90-degree edge here seemed to amplify the distortion when people were viewing it away from that sweet spot. And as a result of that sort of very initial observation, we predominantly used the Cylinder display for virtual environments and primarily used the Wedge display for scientific visualisation, because we knew that this particular display would be amplifying distortions. Well, that's what we noticed. So a colleague of mine has whipped up some demonstrations that, some analysis that analyses and displays the distortions, one of the colleagues on this paper. And the simulation basically starts out by having a user, their two eyeballs at a particular point in front of the display. So this graph here shows three different types of display: planar, flat display, a wedge display, and then a cylindrical 3D display. And then in front of the viewer, we just lay out a grid which has got 10 centimetre squares. Same thing for the wedge. In this particular instance, we're viewing it from this position, but we've got another one of the simulations views it from that position as well. It doesn't really matter where you view it from, but we can simulate it. And then the cylindrical 3D display is from that centre point of the cylinder. And what we notice is that here, as you move half a metre to the right of the viewing position, you get this warping, and the red colour represents an increasing amount of distortion away from the original position. And what's really interesting is that the wedge display at this corner here, you create this, you get this bit of a shear effect, which is what we were noticing. It's sort of an amplification of the distortion at that point. The cylindrical display probably gets approximately the same amount of distortion overall, but since the display is a gentle curve, you don't get this abrupt distortion. Now, moving 1 metre back from the sweet spot, you also get some distortion, as you'd expect, and the 3D mapper already simulated that effect. So you get this form of stretching along this axis. The wedge display sort of somewhat equalises it, but you still do get that stretching effect, and again you get a slight distortion effect there, but it's all fairly gentle, so that's not too much of a problem moving backwards and forwards. Now what I'll show you is some 3D videos of that. It's been captured. I was inspired by Bjorn and put a pair of 3D glasses on my Sony 3D camera here. That's a pair of 3D glasses that have been sort of broken in half and mounted in front of the two lenses of the 3D camera here. It's a little bit noisy, but first I'll show you a 3D test pattern which we often use for our demos. Pretty much every time we do a demo, I show a random dot stereogram at the beginning just to make sure that the glasses are operating. We'll show a sequence with the wedge showing the at the sweet spot, 1 metre to the right, the cylinder at the sweet spot, and the cylinder viewed 1 metre to the right again. So if we could have that video, Dan. So here's the test pattern. Can everyone see 10? There's always one. So this is a virtual environment running in Unity, and the viewing direction is being swept across. So this is repeating of the same sequence again, and you notice that it looks fairly straight and continuous. Now this is 1 metre to the right, and the edge of the display is just here. And can you see that distortion as it sweeps across the object in front of us? And let's repeat that again. So not only is there this shear, but there's also sort of like a horizontal stretching as well as it goes between the two different displays. And back from the sweet spot as well. This is 1 metre back. Oh, sorry, no, quite a few metres back. So there's a bit of stretching there and a little bit of a geometry change, but not too bad. And this is the cylinder display, the 3D test pattern first. As the object is swept across the display here, there's a bit of extreme depth here because we're viewing it a little bit larger than it normally is. And you can see that the geometry is fine. And then 1 metre across from the sweet spot, has anyone noticed that distortion? It's there, but it's not very severe. And then several metres back from the sweet spot, you can see the cylindrical nature of the display, and then we can move around and explore what's happening there. And these are a series of models that have been captured using the 3D reconstruction process. Okay, so if we flick back to the slides. Now, it's important to point out that head tracking can be used to avoid these type of image distortions, but only for one user, and that's obviously not going to be suitable for multiple users. We do have a tracking system fitted to the cylinder display, but just for cost purposes, we don't have that on the Wedge. For multiple viewers, people further away from the sweet spot will receive some level of distortion. The distortion that occurs at the wedge join is more severe and abrupt than with the cylinder display, whereas the distortion on the cylinder is more gentle and hence less obvious. So this analysis reinforces our original decision to use the cylinder display for virtual environments and the wedge for scientific visualisation. Image distortion also occurs when the viewer is at a different height than the sweet spot, and as little as 10 centimetres can be noticed on the wedge at the corner, as I mentioned at the beginning. But again, it's less visible on the cylinder, but we haven't modelled that particular aspect yet. So this aspect of the corner would therefore have some implications if you're thinking of using a Cave 1 display, for example, for group presentations. Now here's a little bit more of a analysis here, or a further a few extra use cases. Adding a wedge display which is viewed from that midpoint within the displays. When you move 1 metre back, again you get that stretching, and if you move half a metre to the right from that spot, the amount of shear is much bigger than when you're at that spot that's further out. So when you've got a group, you're probably more likely to be out here than you are right in the centre here. And the other case that's illustrated here is an omni-stereoscopic viewing condition where the simulation takes into consideration the rotation of the viewer to calculate the geometry. And in that instance, with the viewer just looking straight ahead, you do get some level of distortion in the corners. And if you turned your head to look to the right, as we sort of simulate down here, the geometry would be fairly correct in the centre, and moving further back, yeah, there's a level of distortion there as again, but it's all fairly gentle. So in conclusion, the immersive displays can be used to give large groups of people a virtual environment experience, rather than an individually isolated experience, which you would otherwise have with a head-mounted display, hence enabling collaborative virtual reality. And in our case, the curved surface of a cylindrical 3D display exhibits much less obvious image distortion than that which was present in the wedge display. So, thank you.